Greetings, I'm Professor K, and in this short video presentation, we're going to see how we can go about troubleshooting internet connectivity. Now, there are a number of different reasons why we may not have network connectivity. And we may have LAN or local area connectivity, but we may not be able to get across or to the internet. Now, to begin this troubleshooting process, we have to have a process in place. Now, normally, we start with troubleshooting the physical layer. Are we sure that the networking cable that we have attached to the computer to the DMARC or to the 10 base T-jack on the wall or to a switch is actually good? Do we have a good working network adapter? These are all things that we can touch, and this is what makes them part of the physical layer. So before we start blowing out drivers and replacing adapters and all that fun stuff, we have to make sure that everything is working as it is supposed to. And that can be as simple as a loose network connector with our Ethernet cable, or it could be that we have a bad port on the switch in the wiring closet. But we won't know until we come up with the right process to troubleshoot that connectivity issue. So once I have confirmed that I do have good network connectivity on my local area network, I want to see if I can get over to the default gateway. Now, to do this, I'm just going to ping the default gateway. But how do we find out what the IP address is for the default gateway? Well, we do an ipconfig/all. Just like that, then you hit enter. Now you're going to have to find the local area connector or the network adapter that you're using for connectivity. Now in this case, it's going to be my Ethernet adapter for the Ethernet. Now if we go down through the results that were given to us from the ipconfig/all command, we see that we have a default gateway with an IP address of 10.0.2.2. So next thing we want to do is we want to ping that default gateway to see if we have connectivity all the way to the gateway. And we hit enter. And we see that the ping response comes back in a timely manner, less than 1 millisecond. And we get the results that we have sent 4 packets. We have received 4 packets from the host, in this case our default gateway. Now the next thing we have to do is check our network connectivity to the internet. Now we can do this by pinging any well-known URL. In this case, we're going to ping cisco.com. And if we get a good response, then we know that we do have connectivity to the internet. Let's go ahead and hit enter. Now you'll notice in my results for the ping that we are given the fully qualified domain name for the destination. In this case, it's Cisco, but it's using a different site to filter ping request or any request. And this is nothing more than a security site where all the information that is going to any Cisco site or web page is being filtered to make sure that it's not malicious. And we see that the IP address for this site is 104.111.164.146. We sent 4 packages. The time for delivery was 48 milliseconds. And we see that from the ping statistics, we sent 4 packets, we received 4 packets, and we lost none. Approximate round trip time in milliseconds. The minimum was 44 milliseconds, the maximum was 48 milliseconds, and that gave us an average of 45 milliseconds for this ping to take place. A millisecond is 1/1000th of a second. And though this does ensure or provide us with confirmation that we do have internet access, it does not ensure us that we have a most reliable connectivity to the internet. Now for streaming video or for gaming, we'd want to do a much longer ping of at least 100 ping requests. Now to do this, I'm just going to type in the word ping, give it a space, a -n, 100. Now I'm going to type in that URL one more time, and then I hit enter. So the -n is actually the syntax for the number of ping requests I want to send. So this is going to send 100 ping requests over to the Cisco site, and we should get a better idea of exactly what the connectivity is to this particular URL. So we have completed sending the 100 packets over to the URL for Cisco, and we have sent 100, we've received 100, and we have 0 loss. Now you can look down here at the approximate round trip time in milliseconds, and you can get a better idea of just how good your network connectivity actually is. Well, that tested our connectivity here in the US quite well. And so we know that the connectivity issue is probably not here in the United States. So we may have a problem somewhere else regionally in the world. So how do we test the rest of the globe for connectivity issues? Well, we can use the Regional Internet Registry, and these have websites that are located on the different continents in the world. And we can begin this by typing in www.afrinic.net. And this is the regional internet registry for the continent of Africa. So I can go ahead and I can attempt to ping this one. And we see we get some pretty good responses back. We sent 4 packets, we received 4 packets, no loss, and approximate round trip time in milliseconds. Notice that the farther we get away, that the time is going to increase. So the minimum time for pinging the regional internet registry on the continent of Africa was 393 milliseconds, with a maximum of 395 milliseconds, with an average of 394 milliseconds. Continuing around the globe, we're now going to ping the next regional internet registry, which is located in Australia. So I've typed in that URL, which is www.apnic.net. I'm going to go ahead and hit enter to begin the ping. And the ping request has completed. And we sent, again, 4 packets. We received 4 packets with no loss. Now you'll notice that this one was also much quicker. We have a minimum of 26 milliseconds, a maximum of 32 milliseconds, with an average return round trip of 29 milliseconds. The next regional internet registry site that we can attempt to ping would be located in Europe. And this one is www.ripe.net. Let's go ahead and see if we can ping that. So we've gotten back our ping results, and we sent 4 packets, we received 0, and we lost 4. Now this doesn't necessarily mean that the continent of Europe is down. It usually means that the site is either blocking ICMP traffic or it is down. Now we can confirm either of those just by opening up a web browser and going on over and visiting the web URL of www.ripe.net. And I've already done that, and the site is up. So we can deduce from this that this site is blocking ICMP traffic. The next regional internet registry that we need to attempt to contact using a ping request would be South America. So I've typed in ping www.lacnic.net. I'm going to go ahead and hit enter. And we notice that this ping request is also completed successfully. We sent 4 packets, we received 4, we lost none. The approximate round trip time in milliseconds was a minimum of 347 milliseconds, a maximum of 356 milliseconds, with an average of 350. So that's how we can go about using the ping command to confirm that we do have good internet connectivity around the globe as well as the United States. So all these ping requests were sent across the globe in our mesh network, and they went through many different destinations and ISPs, which consist of routers all over the world. Now, if we would like to see exactly how these ping packets traveled, we can use traceroute. By using traceroute, we can look at the packet as it goes through each one of these ISPs or these routers, and then we can see if that router is responding correctly. We can also see what path we are using to get from point A to point B across the internet. So I've typed in traceroute, trace-RT, space www.cisco.com, and we're going to see what path our ping packet took to get to this URL. So let's go ahead and hit enter. Now you got to be patient because it can take up for 2 minutes for this request to complete. So here we see that the traceroute took us from my default gateway of 192.168.0.1, and it took us to these different ISPs. Now if you would like to know where these ISPs are located or who owns them, all you have to do is open up a web page, go to who is, and then type in that IP address, and it'll give you all the registry information for that particular IP address. So now we see that I traveled from my default gateway, my router, out to another router, and that second request timed out, and that's probably from my ISP. This third request here, this third router, is a 172.31.103.5 address. And like I said, if we just take this and we can see if we can copy that. And what I'll do now, I'll just do a Control-C here. And now I'm going to bring up a web page. And what I'll do is I'll just type in who is. And we'll just go ahead and take that first one there. And we can do a who is here. Now all we have to do is just type in that IP address, or I'm just going to paste it in here. And now we can start to map the location of where these routers are actually located. You can get all the information you want down here. This router is currently located over in Los Angeles. So now we can start mapping the path that our ICMP packets are actually taking over the internet by looking at these routers and their locations. Now in the lab you can continue on doing a traceroute for the other regional internet registries that we previously pinged. And you can also use who is, if you so desire, to go up and look and try to paint a path of where these routers are actually located, so you can see or you can get a physical idea of where all of these routers are actually located around the world. And so we also have websites that will do the same thing as the command line will do inside of our computer. If we want, we can go to the internet and we can perform a traceroute using a web interface. And we also have other tools that will give us a more physical idea of where these routers are located, such as Visual Route. Currently, Visual Route, and I'll take us to there. Visual Route is a product that is or was developed by an outfit called Visualware. And if you go over here, you're going to see that it hasn't been supported very much in the last 10-15 years. At one time, this was an outstanding product for troubleshooting because it allowed you to get a visual of all the different locations around the world where these routers were actually located, as if they were sitting on a map. And then you could ping and you could see the path that the packet took as it went across the globe. And it showed you exactly a physical representation of the router and its current location. But as you can see, that it only supports all the way up to Windows 7, 8, and Server 2012. And currently, this product was built using Java 32-bit. So you won't be able to get the supporting software that you need to run this on a 64-bit system. So the thing you have to remember about using the command line utility traceroute or using a web interface for traceroute is that your results will probably differ because of the location of where these different interactions are taking place. So this particular website, I don't know where it's located, will probably come back with a different result for Cisco.com than my traceroute on my computer from where I'm located. but you can type in the URL or the IP address as best as it can. So here I've gone to another online traceroute utility and I get a much better result. Now, how accurate this is, I'm not going to say, because again, I'm doing it from their location as opposed to my computer, which is where I'm located. And you can see that Cisco.com is actually located 9 hops away from where I'm currently doing this trace route. And I'm not sure where these IP addresses are located, but let's see what happens if we click on the IP address. So this site used Whois to tell me that that last router was actually located in Cambridge, Massachusetts. So there are hundreds of different websites that you can use to conduct this trace route. So you find one that you like. This one happens to be located on Newstar, and it's called Newstar Ultra Tools. But again, there are many different websites that will do the same thing for you. And so that's going to conclude this short video presentation on how we go about troubleshooting internet connectivity using traceroute, ping, and online resources. So if you have any questions or any concerns about any of the information that was presented to you in this short video presentation, please do not hesitate to reach out, contact your instructor, and I'll see you in my next video.